here we go. So today, we're going to continue our look at the turning points, right? Which are the maximums and minimums, yeah? And what we're going to do is we're going to focus on just those places where it stops going up or increasing and starts decreasing, right? And where it starts going back up and down. Because some of them only do like a parabola, only starts going up and then goes down. Some of them have more turning points, etc. So we're going to look at some that have more turning points and how to find them. And we're only really interested in finding the x values because unless it's asking a specific question, we don't need the y value. I don't need to know how high it is. I just need to know that it's increasing during this interval and it's decreasing during this interval. So that's what this lesson is about. Now, if you were doing an application, you'd want to know the actual values, the y values, right? Which is no big deal. All you do is take the x value and plug it into what? The original function. Boom, you've got a y value. Yeah? So that's not difficult to do. So, but we're talking about this because all we want to know is the intervals in which it's increasing or decreasing. And to do that, we need to know those turning points because that's where it changes from one direction to another. Okay? All right. So let's take a look at the lesson. You're going to be very happy because it's very much like what we did before. So remember that the turning points are simply separate where it's increasing and decreasing, right? So if it's increasing and you hit a turning point, that means it's going to start what? Decreasing. If it's decreasing, you hit a turning point, that means it's going to start what? Increasing. Yeah? So that's what happens at those turning points. And to find those turning points, that's simply the x-coordinate of those turning points, the vertexes, right? And there's no need to find the y unless you're specifically asked for them. Again, we're not really interested in how high something is. We're just interested in where it changes, where it changes directions here, okay? And so you're going to see the steps are very similar to what we did last time. To determine, first we need to find out, remember that the turning points are the places where the tangent line is horizontal, so therefore the slope of the tangent line is 0. And the thing that tells you the slope of the tangent line is the differential, right? So what we have to do is first, and here's your steps. First, just take the derivative, differentiate, right? Anytime we're talking about using slope, we need to have the derivative. Step 2, find the x-coordinates. And remember that to find the x-coordinates, all we have to do is replace our f prime of x or our dy dx with what number? 0, right? Because the slope at that point is 0, and that'll allow us to solve for x. So these are exactly the same steps that we used last time we met. Okay? Then we're going to be calculating the gradients either side. So to do that, you simply pick a test point either side to find out what the gradient is on either to the left, between, to the right in this case, because this is a function that's doing something like this. So if this is a turning point and this is a turning point, I need something over here to tell me what's going on. I need something here between those two. Don't care. It doesn't have to be two different values. I can use the same value to tell you because it's going to be doing the same thing. And then I need a value over here. Should sound very familiar. Right? It's identical to what we did last time. Except this time I'm not even interested in finding the y values. And we know that if you plug in the test point and you're calculating gradient, so we're plugging it into the derivative. If you plug it in and it's negative, that means what's happening at the function? It's decreasing, right? The slope is negative, that means decreasing. If you plug it in and you get a positive, that means it is what? Increasing. Okay? And so that's what we're going to be looking at. Now look at the notation that they have. So the function blank, blank, blank is decreasing where negative 1 is less than x and x is less than 4. So in other words, this question was specifically asking you, must have been asking where it's decreasing. And that's all we're interested in. So it's just x is between those two values. Right? And what are those two values? Those are the x values at the turning points. Right? So, very straightforward. So let's just look at an example. Okay. For what values of x are the following functions increasing or decreasing? Now this one they want both. Right? Sometimes they're only going to ask for one, but this function they're going to ask for both. So let's just look at it. We usually do the evens and you do the odds for homework, right? So let's just go to an odd one. Although that odd one that even one is really easy. How about this one? Let's do number 4. Okay? And all they're interested in is decreasing. Do you see that they're asking you for just decreasing for this one? So in order to find out where it's increasing or decreasing, I need to know the gradient. And anytime you see that word gradient, that means take the what? Derivative. Okay? So let's begin by doing that. So g prime of x is equal to 3 times 1 is 3. 3 minus 1 is 2. So 3x squared plus 12x. And of course the derivative of any constant is 0, so we don't need it. Now that we have our derivative, we can then replace that g of x with 0 and then simply solve to find our x values. It's quadratic, so we're going to solve it by factoring. And what's the first thing you look for when you're factoring anything? Common factor. Is there anything common to 3 and 12? 3. They'll both divide by 3. Anything common to x squared and x? Then x. So our common factor is 3x. Now remember, if our common factor was only 3, what could we do with it? Toss it. Who cares? But this time our common factor is not 3. It's 3 what? X. So if it has an x in it, you have to keep it. So let's go back and divide. 3x squared, divide out 3x. It just leaves what? X. Positive 12x, divide out positive 3x. You get what?
4.
What kind of 4? Thank you. Positive 4. We have to have a sign. Okay? Now that we have it factored, we're just going to take each one of those factors and set them equal to 0. So 3x equals 0, and x plus 4 equals 0. You do not have to show as much as I do, but you know that I want to show every bit. Here we'll divide both sides by 3, but that doesn't matter much because it gives us x equals what? 0. Here we'll just subtract the 4, which gives us x equals negative 4. So we have 2 turning points here, yeah? At where x is 0 and x is negative 4, right? I don't care what the graph looks like. We're just looking for where it's decreasing or increasing. So I'm just going to draw a number line and put 0 here and, should have drawn it the other way, and put negative 4 there. I don't care how high it is. All I'm looking for is the interval where it's increasing or decreasing, right? So I need a number over here, so I might pick negative 5. I need a number between negative 4 and 0. I don't like it when we get zeros because then we don't get to use 0 as a test point. What do you want to use? Negative 1? I'm good with 1s, right? Because it just makes the multiplication a little easier, everything easier to figure. It's no big deal. And which, of course, we'll pick over there 1. Now we're going to find where it's increasing or decreasing, right? By simply plugging those into the derivative, okay? Because I'm just looking for the gradient, right? So we're going to be plugging into this thing. If we plug in negative 5, it makes negative 5 squared, which is 25. 3 times positive 25 is 75, right? So that's a big positive number. Plus 12 times negative 5 is negative 60. 75 minus 60 is positive 15, right? So at negative 5, it's positive. Again, do you care about the number? Nope. All we care about is the sign. We know that 4 is a turning point. Let's do negative 1. Negative 1 squared is 1. Just 1. Positive 1, right? Positive 1 times 3 is 3. 12 times negative 1 is negative 12. So therefore at negative 1, 3 minus, that's going to give us a negative. So that means it's decreasing in that interval, right? Again, we're not so concerned with the numbers, so you don't have to show all. Oops, sorry, I didn't mean to. I need that negative. All right, so you could just do a little math in your head or off to the side. Now we'll put in 1. 1 squared is 1 times 3 is 3. 12 times 1 is positive 12, and we don't care about that. We just know it's going to end up being positive, right? Don't care that it's 15. So what is this thing doing then? As we approach negative 4, it is what? Increasing. Then between 4 and 0, it is decreasing. And then after you pass 0, it is starting to increase again. Make sense? Now, this particular question was only asking the interval, well, it's increasing. So it's increasing between these 2 points. So the x is between negative 4 and what? 0. That's where it's increasing. Or decreasing, I'm sorry. I keep saying increasing, and I mean decreasing. Okay. All right?
So is that answer?
This is the answer. It's decreasing for any x that's between negative 4 and 0. Okay. Looks good?
Can we have just written that like as soon as we got the x value?
Yeah.
Well, you're not going to know that it was decreasing between those two. It could have been increasing there.
So if it was increasing, what was the answer?
Well, then it would be decreasing here and here. So it would be until you get to negative 4. So as long as x is greater than negative 4, right? And x is less than, greater than 0. They'd be reversed. Now, if it's between 2, you can write it as one inequality, right? But if it's 2 separate intervals, then you write it as 2 separate things. Good question, though.
What if we only get one x value?
If one x value, then it's only going to be increasing on one side or the other. So it's x is greater than or x is less than. So like if it's a parabola here, and say this is 2, where x equals 2, then it's increasing here. So as long as x is less than what? 2, that's where it's decreasing. If x is greater than 2, then that means it's decreasing. Make sense?
So you take a point either side.
Yeah, you always have to choose a point either side. Okay? All right. Now, the only thing that can happen to you is that you can have them arranged in a funny direction. Does that matter? No. Okay, but it's a cubic, so that means you're going to have to factor out the common factor of x and then solve the quadratic. So you're going to get more turning points, right? How many turning points am I going to get on this one? Can anybody tell me? What's the highest exponent?
3.
So how many turning points are you going to get? Whatever the degree of the equation is, that's how many turning points you're going to have. Okay? All right. Now, we could continue on. Do you want to?
Oh, we could.
Yeah.
All right. As long as you do this as your homework. So do your homework. You guys. So for your homework, on page 32. Okay. Okay. Page 32. All right.